All right, welcome to another video of Chem with Com. We're going to continue stoichiometry. Again, if you haven't watched the basics, go back a video, watch the basics. We're going to get into just good old-fashioned stoichiometry now, right? So we're not going to do any intro. We're just going to go for it and practice some problems. All right, here we go. All right, so again, stoichiometry expands on our previous conversion table, right? What specifically it expands on is now we can transition from moles of something to moles of something else using the chemical equation, right? We're using this new number 4, and this is our number 4. We're going to use the stoichiometric coefficients or the mole ratios between different things in the equation. I keep using this example of uh, a reactant to product, but this can also be used between different reactants or between two products, right? So it's very versatile. So let's try this out. Okay, so this is a sample problem. Number of product molecules generated by a reaction. So let's read through this. How many carbon dioxide molecules are produced when 0.75 moles of propane is combusted according to this equation? So let's summarize, even though there's not many words there, let's summarize it even further. We're looking for, or we're starting with 0.75 moles of propane, which is C3H8. And they're saying, which is right here, how many carbon dioxide molecules are produced when that happens? And we're trying to go to molecules of CO2. All right. Well, again, it's an abstract concept, especially when you're first starting off learning this, but let's do this step by step. You're going to write one reactant or product on one side of that dashed or dotted line. So we're going to put this propane right here, C3H8. Write the other reactant or product on the other side of the dotted line. Well, since we're starting with C3H8 and we want to find CO2, since those are different formulas, we're going to move that. I'm going to try and get this out of the way here so we don't CO2, right? Again, the atom or molecule must have the exact same formula throughout and cannot cross this dashed line without number 3 or number 4. So CO2 is going to remain on the bottom. C3H8 is going to remain at the top. All right, and finish step 2. Step 3, label your start and end points. Well, they're giving us moles of C3H8. So this is our start. We want to end up with units or molecules of CO2. So we're going to start here. We're going to go down. We're going to start out with moles of C3H8. We're going to move down to moles of CO2, right? And since we crossed this arrow, we have to use number 4, which is use the mole ratio. And then we're going to cross this number 2 arrow and we're going to be in molecules of CO2. All right, so here's where we're starting with. We're going to do 3 moles of CO2 on top to 1 mole of C3H8 on the bottom. You can see these cancel out. So we're left with now moles of CO2. But we multiplied that again, so those cancel out. And I'll show you where this step is. This is step 4. This is the mole ratio, sorry, equation 4, mole ratio of the chemical equation. This here is equation number 2, right? Using Avogadro's number. We put moles of CO2 on the bottom because that's what we're trying to cancel out. And we have units, which are molecules or atoms, on top. Those cancel out, and we got 1.4 times 10 to the 24th. We'll do this again. I just wanted to have a slide that kind of showed you through that. So again, we moved through the boxes only using the arrows and used the numbered conversion factors listed. So we used number 4 first and then number 2. So now we know that 0.75 moles of C3H8 produce 1.4 times 10 to the 24th molecules of carbon dioxide. All right, let's do this again. Step 1 through 4 on our next problem. Or is this the same thing? This might be the same thing. Let's do it without using those play-by-plays, right? So let's start here. We're trying to do 0.75 moles of propane. We're trying to get to molecules of CO2. So because these are different formulas, one's going to be up top, one's going to be on the bottom. We're just going to go a slightly different way here, right? This is our start. We're starting with 0.75 moles of something. So this is our start. I'm going to label this start. We're going to go to molecules of CO2. So that's where we are, atoms or molecules. So we're going to cross arrow 4, and then we're going to cross arrow 2. So let's do that. 0.75 moles of propane, C3H8. Since we're crossing 4, we're going to need the mole ratio of the chemical equation. Let's look at it more closely here. 1, and we're trying to go here, which is a 1:3 ratio. Let's write that out. Since we have moles of C3H8 on top, we have to have moles of C3H8 on the bottom, propane, right? And since there's no number there, it's a 1. Up top is going to be 3 moles of CO2. All right, those then let's continue. Let's cancel out what's supposed to cancel out so far. Moles of propane, moles of propane. All right, that leaves now moles of CO2 up top. So let's continue. So now we are here at moles of CO2. Now we need to go to molecules of CO2. So we need to use number 2. It says use Avogadro's number, 6.022 times 10 to the 23rd units. And again, units are molecules or atoms in this class usually. We need moles of CO2 on the bottom. Up top, we need the 6.022 times 10 to the 23rd molecules CO2. All right. Let's see what else cancels out. If you look at what cancels out, moles of CO2 cancel out now, and we're left with molecules of CO2 is what we wanted. So I'm going to put here molecules CO2. Let's do the math here. All right. Oops. All right, so let's do another calculator. Clear this. So it was 0.75, right? 0.75 times 3 divided by 1. And then times, and I'm going to put this in parentheses, 6.022 times second 10 to the 23rd. I'm going to use this little arrow to go to the right, put a close parentheses, and then enter. So I got 1.35, or it's going to be 1.4, and that e to the 24, that's going to be the same as 10 to the 24. So I'm going to write both of those. So it's going to be 1.4 times 10 to the 24th molecules of CO2. Or what you'll see on your calculator sometimes is 1.4 uppercase E, but small, 24, right? Either one of those are correct. I'm going to leave it in this form. This is basically a calculator annotation. You never want to report that Or not never, but you probably don't want to report that on an exam or anything. It just looks weird. It's not like what we normally use. All right, let's continue now. Let's do this with something we don't know. All right, let's set this up again. How many NH3 molecules are produced by the reaction of 4 moles of calcium hydroxide? So look what we're doing. We're going from calcium hydroxide. We're going to look for moles or molecules of ammonia. Let's try this. Let's write it out again. We'll say 4.0 moles of calcium hydroxide. And we're trying to figure out molecules of NH3. All right, two different formulas, 1 and 2. I'm going to write one, doesn't matter where. Let's just put NH3 here. And then calcium hydroxide here. And you'll get good at this, so you don't need the table, this little conversion table, but it helps while you're learning. It helps you focus, what you're trying to do. Let's check it out. So we're starting with moles of calcium hydroxide. This is our start. Our end is molecules of NH3. So this is our end. So we're going to cross box 4. So we have to use the mole ratio, the chemical equation, and then Avogadro's number. So let's try it out. 4.0 moles calcium hydroxide. We know we're going to need the mole ratio, but we're going to need the moles of calcium hydroxide on the bottom because we need that to cancel out. Here, if there's no number, it's going to be a 1. Then we put the moles of NH3 is 2 moles of ammonia, 2 moles of NH3. Let's cancel out what cancels out. Moles of calcium hydroxide, we're done. What's up top is this moles of NH3. Well, now we are here. We cross arrow 2, and it says use Avogadro's number. 6.022 times 10 to the 23rd units equals 1 mole. So moles we're going to put on the bottom because we have it up top here. So we're going to say 1 mole of NH3 is equal to 6.022 times 10 to the 23rd molecules of NH3. All right, so let's cancel out what cancels out again. Boom and boom. So now we're left with molecules of NH3. Oops, wrong pen color. There you go. All right, so I'm going to write our units first. I like doing the units first to make sure we are doing this correctly. I said it's like a free check to make sure to double check. So let's try this out. So 4 times 2. Let's do a different calculator. Clear this. 4 times 2 times. Again, if you don't know how to use or how to use your calculator that well, I recommend putting anything in exponential notation in brackets. Once you learn how, you don't have to do this, but it's good to learn. It's good to practice this way. And then we'll say times 10 to the 23rd. I'm going to drag the arrow over a bit, put a closed parentheses. So let's check it out. 4.8 times 10 to the 24th. Okay, so this is 4.8 times 10 to the 24th molecules of NH3. Okay. All right, another one down. Again, stoichiometry problem. What is the centerpiece here are the mole ratios. And that's coming from these numbers in front of those reactants or products. Let's check it out. Okay. What mass, and let's write this out again. Let's find a spot to write this. Okay, mass of sodium hydroxide would be required to produce 16 grams of the antacid milk of magnesia, which is magnesium hydroxide. So let's do it. We have 16 grams of magnesium hydroxide. And we're trying to get to mass, this is also grams of sodium hydroxide. So let's write our formulas. So we'll say magnesium hydroxide and NaOH, sodium hydroxide. Our start is grams, so this is our start. This is our path. Oh, sorry, let's figure our end. Our end is grams of sodium hydroxide. So this is our end. All right, so how to do this is we cross first arrow 1, which is grams per mole from the periodic table. Then we go from moles of magnesium hydroxide to moles of sodium hydroxide using number 4, the mole ratio of the chemical equation, which is a 2 sodium hydroxide to 1 magnesium hydroxide mole ratio. Last step is we cross this other number 1, and we're going from moles of sodium hydroxide to now grams of sodium hydroxide, right? So a pretty long problem. Let's check it out. Let's start it. So one thing I know we're going to need, and I'm kind of doing this in advance, is I know we're going to need the the molar masses of magnesium hydroxide and sodium hydroxide. So I'm going to calculate those first. You might not know that. Once you start working through the problem, you'll be like, oh, okay, well, I need this and I need that. Well, here we have magnesium. We have one of these. Oxygen, we have 2. Hydrogen, we have 2. Each of those magnesiums, again, these are from the periodic table, 24.31 grams per mole. Oxygen is 16.00 grams per mole. Hydrogen is 1.008 grams per mole. And let's do this. I'm going to do this in the calculator to show you how it's done. All right, so let's do this. This is how I'll do it here. Let's clear this. We have 1 magnesium, and that's 24.31 grams per mole. Right? Plus, we have parentheses 2 oxygen, which is 16.00 grams per mole. Plus, and then we had 2 hydrogen, 2 times 1.008 grams per mole. Add it all up, we got 58.326 grams per mole. 58.326 grams per mole. Let's do sodium hydroxide, right? Which is just sodium times 1, oxygen times 1, hydrogen times 1, 22.99 grams per mole. Oxygen is 16.00 grams per mole. Hydrogen is 1.008 grams per mole. Let's do the math. So let's do another calculator. It was just, let's clear this, 22.99 plus 16 for the oxygen plus for the hydrogen, 1.008, 39.998 grams per mole. Okay, so now we have our molar masses. Now let's do them. Let's go. We have 16 grams of magnesium hydroxide, OH2. We want to use this grams per mole. We see grams up top here, so we have to have the grams on the bottom. 58.326 grams of, specifically, magnesium hydroxide on the bottom, and we have 1 mole of magnesium hydroxide up top. Let's do the math. So 16 divided by 58.326. 16 divided by 58.326. 0.236. Let me just make sure I did that right. Sorry, 326. Let's go back. 326, right? Just a one number difference might throw you off. All right, I'm going to use a digit past the significant digit. So we used 16. So we're going to use 0.274. You don't want to round too early. And this is moles of magnesium hydroxide. All right, let's cancel out what cancels out. We should have done this before, but grams of magnesium hydroxide cancel out. We're left with now moles of magnesium hydroxide. That's what we should have. All right. Now we're going to do this next step, this next part in next two steps in one part. I think I said we're going to keep the, no, 0.274. Perfect. Moles of magnesium hydroxide. We're going to now do the mole ratio. And we have to put the one magnesium hydroxide on the bottom because that's what we're trying to cancel out. Up top is going to be the 2 moles of sodium hydroxide. All right, let's look what cancels out. Moles of magnesium hydroxide cancel out. Actually, I'll do this one in 3 steps. Next one, I'll just do one long equation and we can see how that works for us. So again, 0.274 times 2. We're going to do that. Switch calculators. 0.274 times 2. 0.548. Well, now look what the units are. They're now moles of sodium hydroxide. So we started here. We went to moles of magnesium hydroxide. Then we went to now moles, sorry, we went to from moles of magnesium hydroxide to moles of sodium hydroxide. Now we're going to do our last step. We're going to use our grams per mole to figure out the grams of sodium hydroxide. 0.548 moles of sodium hydroxide. Now, if you look here, we want the moles on the bottom. So it's 1 mole of sodium hydroxide. And remember, we're using this number here. It's 39.998 grams of sodium hydroxide per 1 mole of sodium hydroxide. So grams go up top here. Let's cancel out the stuff. Cancel, cancel. We're left with grams of sodium hydroxide, which is perfect. So grams of sodium hydroxide. All right. So we want to end up with 2 significant figures at the end, but we have a bunch here. So 0.548. Clear 0.548 times 39.998. And we got 21.9, or we're going to say 22 grams of sodium hydroxide. All right, long problem. We had to trace our way through the problem, right? But we made it through, and every time we crossed an arrow, we had to use a specific either conversion rate or equation or mole ratio, right? So make sure you're paying attention to the transitions, which are the arrows. All right, let's do another one. Let's write this out. Again, we're going to get slowly faster, but you can also pause it, rewind it, watch me in slow motion. That might be torture, but it's still an option. All right. What mass of gallium oxide, they're asking. They're saying, whoa, what mass of gallium oxide, right? Might be gallium 3 oxide, if that's a thing. I'm not sure if this is a, what do you go, fixed charge ion or not. But we're looking for, oh, mass, so grams of Ga2O3. All right, we're starting off with 29.0 grams of just straight up gallium metal. Oops. of just straight up gallium. All right, let's figure this out. Let's do the molar mass. Let's write it here. Let's say we're starting with gallium here. Here we're going from Ga2O3. This is our start, right? We're starting with gallium metal, grams. Crossing arrow 1 like we did before. Go to moles of gallium. Crossing arrow, sorry, with arrow 1 going to moles of gallium. Crossing arrow 4 gives us now moles of Ga2O3, gallium oxide. And then we're crossing arrow 1 again, which is going to be now grams of gallium oxide, right? So another kind of two-part conversion. Let's get the gallium molar mass done here. So Ga2O3, we have gallium times 2. Each gallium you see here is 69.72 grams per mole. We have oxygen, and that's times 3, 16.00 grams per mole. Let's do that. So 69.72. All right, clear all this. We have 2 times 69.72, close parentheses, plus, and then open parentheses, 16 times 3, close parentheses. We have 187.44. Again, 2, and that's grams per mole. 2 gallium, 3 oxygen, 69.72. So you have 187.44 grams per mole. All right. We're going to do this in one equation. I'm going to pause and cancel things out so we can, walk our way through this. 29.0 grams gallium. We cross arrow 1. We have to use the grams per mole. Well, that's just straight up 69.72 grams per mole. Grams are up top here. We have to have grams on the bottom here. 69.72 grams of gallium to 1 mole of gallium. Let's just pause, cancel what cancels out. Grams of gallium. Cool. Let's move on. Next one. We know we're going to have to cross arrow 4. Here we need the mole ratio. This is where we're going to use those coefficients in front of the products and reactants. So 4 and 2. I need the gallium metal on the bottom to cancel out with this gallium metal on top. So now I put 4 moles gallium. Here is going to be 2 moles gallium oxide or gallium-3 oxide, right? So let's cancel out what cancels out and move on. This moles of gallium cancels out. Now we did this. We started here. We went here. Now we are here. Now we need to cross that arrow 1 and convert that to now grams of gallium oxide. So let's check it out. Because moles is up top here, we need moles on the bottom here. Gallium oxide. And we're going to use this number here. 187.44 grams of gallium oxide. All right, last cancel out. Moles of gallium oxide. Done. All right, let's crank out the math now. The units are going to be now grams of gallium oxide. It's going to be this 29 times 1 divided by 69.72 times 2 divided by 4 times 187.44 divided by 1. Let's check it out. Oops. Let's find the calculator. So I'm going to, let's see here. It's, forgot what the numbers were already. 29. And if you're not too sure about the ones, leave them in. Times 1 divided by And I think it was one, no, 69.72. 69.72, close parentheses, times, open parentheses, 2 divided by 4, close parentheses, times, open parentheses, 187.44, 187.44 divided by 1, close parentheses. All right, that was a long problem. Let's hit enter. Hopefully that worked. 38.98. We have 3 digits, so we'll say 38.98. Right, but we want 3 digits. We're going to cut it off there, and it's going to be 39.0 grams of gallium oxide. And I think I put the answer below. Let's just check it out, make sure it was, where are we at? Yep, 39.0 grams of gallium oxide. So we are golden, right? Same as last problem. We just did it all in one operation. And it was, I don't know, could be easier for you, harder for you, but if you're getting confused, go back in the last one, do it in steps, and then practice this one in steps, right? It's difficult, but you can do it. Again, the star of this show is the mole ratio here, and that's the 4 to 2 that we saw, and that's allowing us to transition from moles of one thing to moles of something else using that chemical equation. All right, let's keep going. Uh, We just move this around. All right, back in business. What mass of oxygen gas from the air is consumed in the combustion of 702 grams of octane C8H18, which is one of the principal components of gasoline? This is the balanced equation with the different coefficients. Let's check it out. Let's write out what we're going to do. So they're saying we're starting from 702 grams of octane, and we're trying to figure out mass, which is now grams of O2. So we're going from this to this. All right, let's check it out. I'm going to do, let's label this stuff. So C8H18O2. We're starting off with grams, so I'm going to box this up and say start. We're going to figure out here, because this is grams of O2 at the end. So same thing, cross box 1, grams per mole periodic table. Cross box 4, we're going to use the mole ratio of the chemical equation. And then we're going to go back and cross box 1 again, which is the grams per mole from the periodic table, but now specifically for O2. Let's get the molar masses down here. So C8H18, we have carbon times 8 times 12.01 grams per mole. We have hydrogen times 18, and that's 1.008 grams per mole. Let's do the math. Let's do a different calculator just so we can keep moving back and forth to try different ones. I believe, if I can remember right, it was 8, because octane, oct times 12.01 grams per mole, close parentheses, plus, open parentheses, 18 times 1.008 grams per mole, close parentheses. We have 114.224, 114.224. So 114.224 grams per mole. Let's do the oxygen. O2 is just oxygen times 2 times 16 grams per mole. That's going to be 32 grams per mole. All right, we're ready to rock. Let's do this in one shot. So they say we're starting out at 702 grams octane, ACH18. So again, since grams are on top here, we're gonna have grams on the bottom. So that's 114.2. Let me fix that. It should be 224 grams of octane to 1 mole of octane. All right, sorry. We're gonna do everything in one. I'm gonna cancel out first just to give you a visual of what we need to do next, right? And we started here. We are now here. We're at moles of C8H18. So we need to cross arrow 4 using the mole ratio. We have a 2 to 25 ratio. So on the bottom needs to be 2 moles of C8H18. On the top is 25 moles of O2. All right, let's cancel out some stuff. Moles of C8H18, moles of C8H18. It leaves moles of O2 up top. So here we're at moles of O2. We are now going to cross arrow 1 again, meaning we need to use the grams per mole from the periodic table. Grams are going to be on the top now because moles are on the top here. So moles need to go on the bottom. So here we put 32.00 grams of O2 up top. Last cancellation. This one in moles of O2. Let's put that into our calculator. Let's use a different calculator this time. So, and I'll have to go back and forth because I can't remember all that. So, actually, let's stay on that one. We haven't done one of these ones with this calculator. So it's going to be 702 times, open parentheses, 1 divided by 114. I think it was 224, hopefully. I'm going to move that over a bit, put the close parentheses, times, open parentheses, 25 divided by 2. So 25 divided by 2, move the arrow over, close parentheses, times, this should be 32 over 1. So open parentheses, 32 divided by 1. Like I said, you don't have to do it this way. I recommend doing it this way just until you learn. And then once you learn how to use your calculator better, you can skip all these extra steps. Save you a few minutes on the exam. All right. So we have 2458. What does that mean? Let's put it into our problem. 2458 grams of O2. We need 3 significant figures. We drop the line here. So it becomes 2460 grams of O2. 3 sig figs, 3 sig figs. That's all we were trying to do, right? And you could all go to this. This is also 2.46 times 10 to the 123 grams of O2, or this is also 2.46 kilograms of O2. These are all the same kind of number. They all mean the same thing. And so if something pops on an exam, you should be able to move back and forth between those 2 different formats or 3 different formats. All right, last one for this video. Is it last one? Yeah, last one. All right, what mass of carbon monoxide is required to react with 25.13 grams of iron oxide? Whoa, that's a lot of stuff going on. All right, let's do that. Let's write it out. 25.13 grams iron, and that's specifically 3 oxide. And we're going to grams of carbon monoxide, not monoxide. All right, since I know, let's label this Fe2O3 CO. This is our start. And it looks like it's the same process, right? But I want to point out, we could go across this way, down here, all the way back, right? Or we could have, this conversion table is very mobile. It lets you do whatever you kind of need to. So whatever the question is asking for, it just, we had 3 or 4 examples in the row kind of doing the same thing, but we could have started here, went straight across, right? If it was the same formula. So, yep, just practice using this and you'll get a lot better at it, and then you won't even need it. All right, so this is our end. Again, cross arrow 1, grams per mole, periodic table, cross arrow 4, mole ratio, chemical equation, cross arrow 1, grams per mole, periodic table. Let's do the molar masses first. Fe2O3, we have iron times 2, and that's 55.85 grams per mole. Oxygen times 3, 48.00 grams per mole. So let's do that. Clear this. Close open parentheses, 55.85 times 2. Close parentheses plus open parentheses 16 times 3. Close parentheses 159.7 grams per mole. Carbon monoxide, you're just adding because we have carbon when we have 1, oxygen we have 1. That's 12.01 grams per mole. This is 16.00 grams per mole. And we have 28.01 grams per mole for carbon monoxide. All right, let's go for it. 25.13 grams. Iron 3 oxide. We know we're going to need grams on the bottom, so we have to put the 159.7 grams of iron 3 oxide. Oops, I wrote that backwards. Let me fix that. Fe2O3. And then we have 1 mole of Fe2O3. Well, these cancel out. So we're left with moles of Fe2O3 up top. So we need now moles of Fe2O3 on the bottom, and we're doing now the mole ratio, and that is a 1 to 3. So here we're doing a 1 mole of iron 3 oxide to 3 moles of carbon monoxide. Let's cancel these out again. Or not again, but these other ones, right? Those all cancel out. Last one. We finished here. We're crossing arrow 1 again. Carbon monoxide, we're going from moles to grams. That's going to be 28.01 grams of carbon monoxide to 1 mole of carbon monoxide. Now the last cancellation, and we're left with grams of carbon monoxide, which is what we wanted, right? Grams of carbon monoxide. Let's plug this into our calculator. We'll come back and forth because I can't remember all these numbers, so let's go for it. Clear this. We have 25.13 times 1 divided by 159.7. Close parentheses. Multiply by, believe it's 3 divided by 1. Again, if you're not sure what to do with the ones, just leave them in. You don't really need them. But at this point, I'm not sure what you know and you don't know. But if you don't know, keep them in. 28.01 divided by 1, close parentheses, enter. 13.222. So we need 4 sig figs. So we need 13.22 grams of carbon monoxide. Let's check our answer. All right, looking good. All right, that's it. Again, if this is too tough, go back to the stoichiometry basics. Really, really, really understand that before moving on to this lecture, because this is uh, very far advanced in the basics. So if you need help, go back to that one, do it a few times, then do this one again. All right, that wraps up the video. I will catch you next time. And yeah, for part 3 and for part 4. All right, catch y'all later.